Okay, so today we're going to be working through AP Free Response Question 4 from the 2017 exam. This question is a differential equation question. At time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0, and the internal temperature of the potato is greater than 27 degrees for all times t greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dh dt equals -1/4 h minus 27, where h of t is measured in degrees Celsius and h of 0 equals 91. Okay, so right here, I would stop for just a second and just identify this is a differential equation. Okay, they're giving that to you. So h of t, the function, is the temperature of the potato. Oops, can't spell. Okay, so we have that information before moving on with the problem. Part A is write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So the first part of this question is asking us to write an equation of a tangent line. Okay, and we're going to do that when t equals 0. So anytime we need to write the equation of a tangent line, we want to remember we need the point, we need the slope, and then I like to plug it into my point-slope formula, and then I can arrange it after if I need to. So our point here was given to us. This piece of information means when I plug 0 into the function, I get 91. So the point is 0, 91. And now our slope, here's where we have to remember that dh dt is the derivative of this function. It's the derivative of the temperature function. So we have our derivative. We just need to evaluate that at the point 0, 91. Okay, so we're going to plug this point into that function. When I go to see how I'm going to do that, I realize I really only need the h value. So I really only need to plug the 91. -1/4, 91 minus 27, -1/4. This is 64. Oh, yes. So our slope, dh dt, is -16. Okay. So now that I have my point and I have my slope at that point, I can plug it into my formula. Y minus 91, -16, x minus 0. There's no real need to rewrite this, but because this is a 0, I probably would go ahead and kind of clean it up, only because it just makes it easier to look at and deal with. So there's my equation. Okay. Now, it's okay here if this is x's and y's. If you wanted to write it back in terms of h and t's, that's fine, but these are basically dummy variables, and they're okay. We want to evaluate this when t is 3, so this means we're going to plug 3 in for x. -16 times 3 plus 91, and we get 43 degrees, and that would be in Celsius. So, the internal temperature of the potato, the approximate. Remember, this is only an approximate value. The approximate internal temperature of the potato at t equals 3 is 43 degrees Celsius. And there you have it. Okay, so moving on to the next part of the question. Use d squared h dt squared to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. So now here we have to think about how we're going to deal with this. What is d squared h over dt squared? What does that represent to us, or how is that going to help us? Think back to the second derivative and what it tells us. The second derivative tells us about the concavity of a function. Okay, and this is going to help us because determine on the concavity of the function, it will help us determine whether or not we have an underestimate or an overestimate. Remember, when f double prime is greater than 0, our curve is concave up. And when f double prime is less than 0, our curve is concave down. Now, how does this kind of tie into what we're dealing with? Well, if our function is concave up, we can either have this situation or that situation. If we have a tangent line, the function value, the actual function value, the relationship here, the approximate value is going to be an underestimate because it's below the curve. Underestimate. And if our curve is concave down, we can have this situation or that situation. In which case, if we're comparing the tangent line and the curve, the approximate value is going to be an underestimate, regardless of if the function is increasing or decreasing. So when we're determining that, what to do about this particular situation in the problem, we want to kind of think about that when we're analyzing our second derivative. So we're going to go back up again, and we're going to start with dh dt, and we have to find the second derivative. So d squared h, I'm going to take a step back for 1 second here. When I look at this function, I really don't like the form it's in, so I'm going to distribute it out so I can apply my rules a lot easier. Negative 1/4 h minus plus 27 over 4. Now I'm going to move on from here. D squared h over dt squared. So that's the second derivative. Negative 1/4 dh dt. And that's just going to drop out. And if you recall in class, we would continue through. Negative 1/4. Now for dh dt, I'm going to go back up to the original and put that in, because that's my dh dt. So the rule for the second derivative here is 1 over 16 1 over 16 h minus 27. Now using this rule, I can go ahead and I can substitute in. Now remember, we set up the derivative using t equals 0. So I'm going to evaluate this at 0.91. So I'm going to plug 91 in here, right? We want to know what's happening at the curve when t equals 0. And my second derivative now this would be 64. It's going to be a positive value. I don't care. I don't care if it's what the actual number is. I only care if this number is positive or negative. It basically works out to be positive 4, if you were actually concerned with the number. However, we only need to use this information. Since the second derivative is positive, that means the curve is concave up. So since d squared h over dt squared is positive at t equals 0, h is concave up. So the answer to part A is an underestimate. And that's how you would go about a question of that nature. Okay. Now some of you, just to take a step back for one moment, some of you may have realized right here, that we want the value at this when t equals 0, and we already found that up above. So you could have actually just used this answer here and plugged it in there. That would be another way to go about doing it. But I actually wanted to go through these steps just to show you in case you had to actually work out and find the second derivative for something. Now the last part of this question, they're kind of switching functions up on you, which is okay. They'll do that. They'll give you pieces here, pieces there. For t less than 10, an alternate model for internal temperature of the potato at time t is the function g. So now they're giving you a new differential equation. So this differential equation we're going to use to answer this problem. G of 0 is 91. Okay, so we know 0, 91 is a point on that curve. And we want to find the expression for g of t. This just means find the particular solution. To the differential equation that was given. And then based on this model, we're going to find the internal temperature at time t equals 3. So we're going to begin by writing down our differential equation. And ironically, this was the last lesson we had in school together. Okay, so we want to solve this differential equation. We have to get the g's with the g's and the t's with the t's. Remember, we're going to separate. We're going to separate our variables. So I'm going to cross multiply 1 over g minus 27 raised to the 2/3 dg equals negative. And I like to put a 1 there sometimes to remind me that there is something out in front of that dt. Now we want to integrate. So now I would take the antiderivative of each side. To take the antiderivative of this side, I'm going to have to rewrite this so I can apply my rules. The antiderivative over here becomes g minus 27, add 1, divide by negative 1/3 means I'm multiplying by 3. And on this side, I get my negative t plus c. Now moving on, we're going to solve. We want to get this as g equals. So we're going to isolate this. G minus 27 raised to the 1/3 power equals negative 1/3 t. Remember, even though I'm dividing, I'm just going to leave my c alone till the very end. In order to get g by itself, we have to undo. So we're going to cube both sides. G minus 27 equals negative 1/3 t plus c cubed. And the last step, g equals, we're going to add our 27 over. Now, hopefully most of you guys remember, this is our general solution. We were asked to find the particular solution at 0.91. So basically at this point we have to do just a tiny bit more work. Okay. So I know when I plug in 0 for t, I get 91 for g. And remember, our goal here is we want to find what c is. So I'm going to subtract the 27 over. I get 64. Negative 1/3 times 0 is just 0. 64 equals c cubed. So c equals 4. So our expression now, our particular solution, for g of t, is we're going to go back in and we're going to replace our c value. So g is going to equal negative 1/3 t plus 4 cubed plus 27. So this is going to be the expression for g of t, and I guess I should really make this proper notation here. This answers the first part of the question. Now we want to find the internal temperature when t equals 3. So we're going to plug 3 in. And really here you could do this math pretty much in your head. G of 3 is going to be -1, -1 plus 4 is 3, 3 cubed is 27, so we get 54 degrees Celsius. So using this model, the internal temperature of the potato at t equals 3 is 54 degrees Celsius. And there you have it. We have just reviewed a differential equation. Good luck and talk to you soon.